Capacítate. No tienes que normas. Aún ya no capacitación para ti. Ya me dijo mi nombre. Es la última que trae.
Muy buenos días a todos. Oscar, ¿me confirmas si me escuchas bien? Muy buenos días a todos. Muchas gracias por conectarse a la capacitación del día de hoy. Les recordamos, por favor, apagar sus micrófonos y cámaras. Como saben, hay una sesión de preguntas y respuestas donde ustedes pueden activar su micrófono o escribir su duda en el chat. Les recuerdo que esta capacitación es grabada y la pueden encontrar en nuestro canal de YouTube de 𝗣𝗥𝗢𝗚𝗥𝗢𝗡𝗦. Y les recordamos que estamos en el tema 6, Anclajes químicos para la construcción, de nuestro primer bloque de estas capacitaciones del segmento Construcción. Le damos la bienvenida a 𝗣𝗥𝗢𝗚𝗥𝗔 y a 𝗘𝗦𝗧𝗏, que son soporte técnico de Euclid Chemical. Esta capacitación es en inglés. Esta capacitación la van a encontrar grabada, traducida al español en nuestro canal de YouTube de 𝗣𝗥𝗢𝗥𝗢𝗏. Oscar, ¿me ayudas para avisarles?
Sorry. 𝗘𝗦𝗧𝗏, 𝗣𝗥𝗢𝗢𝗏, well, we all have introduced all to the training. So please, can you help us with your presentation?
Hello, everyone. It's great to be here. I think there are still some people joining the meeting. Trying to. That's the good number, 70. So once again, it's great to be here and introducing a little bit and talking about chemical anchoring. And I'm going to start and share my screen. Okay, a few more people. That's the good news. So Oscar, just confirm if it's clear. I'm talking, you can hear me.
Yep, everything right. We can hear you very well. And
excellent.
We'll just waiting for your screen.
Excellent, that's fine. Can you see my screen?
Yeah,
excellent.
We can see.
Hello, everyone. I'm going to start a few more people. Let's admit them. Oscar, would you please just make sure everybody has admitted, because I can't see the meeting page now, and it's good if you just let them in. Thank you. So today we're going to. Yeah, go on.
Sorry. Just we are going to let all the questions at the end of the presentation. Mariel has talked about it, but I want to remember to you, all questions is going to be at the end of the presentation.
I think we can use the chat to put the questions there. So some of them will be quicker this way. I can go through them and then give more concise answers after the presentation, instead of waiting the end of the presentation and have all the questions answered.
Okay. Fine, so go ahead, please.
Reza,
Reza, we can't hear you.
Reza, we can't hear you.
Reza, you're on mute.
Can you hear me now?
Yep.
Yeah, yeah.
Yeah, okay. Just bear with me. Yeah, excellent. So today we're going to introduce and talk about chemical anchoring. It's going to be just an introduction, so we are not going to that much details, but it's good because we're going to speak about the most important aspects of chemical anchoring. So a little bit about ourselves. I'm Reza Jafari. I've got bachelor and master degree in civil and structural engineering. My journey started around chemical anchoring when I was at the uni, and then I started to work around chemical anchorings. And at the moment, I'm actively working around different types of anchors, and I hope we can give you some useful information today. Trezor, can you introduce yourself?
Well, my name is 𝗘𝗦𝗧𝗥𝗧𝗧𝗏. So I'm a civil engineer, and I've also got a PhD in civil engineering, working on tunnel segments made of fiber reinforced concrete. The world of anchoring is relatively new to me, but not the world of designing, because I've also had a background in a design civil infrastructure design firm. So yeah, I'm here and I'm happy to support.
Yeah, thank you very much. A wide spectrum of bonded anchors are currently available around the world. There are different types of categories and, let's say, classification of them, but the most standard version is dividing them into main groups: capsule systems and injection systems. When it comes to capsule systems, we are talking about different types of chemicals that are inside a capsule type of anchoring. The other category is injection systems, and it's divided into three groups. Today, our focus is more around organic bonding material, which is going to basically cover unsaturated polyester, vinyl ester, and epoxy. So our focus is here, and just please bear in mind that when it comes to chemical anchoring, there are a lot of different types of them on the market, but today's focus is only on organic bonding materials. When it comes to bonded anchors and injection systems, we are talking about cartridges. Cartridges are usually they contain two different types of chemicals. Usually, universally, they call it part A and part B as two components. So resin plus hardener and catalyst. So what does it mean? It means we have one chemical here and another chemical here. When they're coming out and then going into the mixing nozzle, that mixing nozzle is going to be connected here. This is the static mixer. Those two chemicals are started to mix into each other, and then the final compound that is coming out of the mixer is two chemicals that they got together and start to react. So we are dealing with the type of materials that reacting to each other. So we are dealing with a chemical reaction, and that chemical reaction resulted in a bond between two different materials. So when we are talking about two different materials, we are talking about inserts and base. The inserts can be threaded rods or rebars. We have more, let's say, inserts available on the market, but today we are just going to focus on threaded rods and rebar. The practical reason is because they are basically covering most of the applications. And talking about base materials, we are talking about something that we want to connect these elements or inserts to them. Mainly, we are talking about reinforced concrete and in different cases, when it comes to other substrates, we are talking about masonry applications, which is like concrete blocks and basically brickworks. So what we do is basically having a very complex systems of chemicals, and then they are helping to have inserts connected to the base. Let's talk about mechanical anchors versus chemical anchors. So when it comes to chemical anchoring, the load transfer mechanism is mostly around mechanical interlock and friction. So basically we have a space around the anchor that is, when we have a load, well, whatever load is that, is a tension load here, for instance, then that mechanical interlock helps the system to transfer the load. When it comes to friction, it's all about those expansion anchors into the concrete. So when we have these kind of anchors, it's a true bolt here, a wedge anchor. When we have them installed, then we have like an expanded part of the anchor. So this cone is just going through the sleeves and imposing some of the loads to the side. So we say we have friction mechanism. And finally, we have bond. What does it mean? It means we have the insert, we have the chemical all around the insert, and then we have the base material, which is concrete around. So basically, it's gluing our insert to the base. A picture here shows how the effect of being close to an edge for a case of having a mechanical anchor. So mechanical anchors generate a lot of expansions around this area. And if we are, for instance, in this case, installing a post to concrete or base, and we are close to the concrete edge, then we have failures. This failure is not because of the load or anything around the anchors or the post, but it's simply because of that expansion. So that internal expansion into the base causing the base material to fail even before it is in normal intended use or normal in service of that particular element. Chemical anchors in general are sensitives. They are sensitive to different things. The most important ones is the resin type. When we have a different resin, even if it's produced by the same manufacturer, we have different characteristics. So the type of the chemicals is something that is going to change the behavior of the chemical. The second thing that chemical anchors have sensitivity to is the anchor rod diameter. So the diameter of the inserts, if you remember, I was showing the threaded rod and rebar. The size of that element is going to affect the bond strength or the resistance of the system. The next element that is going to affect the chemical anchors in general is concrete class. Concrete class can be from C20 25 to C50 60s. These numbers can be different around the world, but at the end of the day, they are all talking about the compressive strength of the concrete. So if you're dealing with different concretes, it means the behavior of the chemical anchor is different. The next one is concrete saturation. Is it the concrete dry? Is it the concrete wet? Is it a flooded hole? What the meaning of flooded holes means you have a hole on the job site and the water is basically inside the hole. So these things can affect the chemical anchors. The next one is drilling methods. What type of drilling methods are used on the job site? If it's a normal hammer drilling, if it's a compressed air drilling, if it's diamond drilling, what type of drilling is that? If the new methods on the job sites around drilling is dustless drilling. Dustless drilling is basically as another method introduced to help the operators, because obviously it's collecting the dust and in a long term is less harm to the operators. So again, that drilling method has effects on chemical anchor sensitivity, chemical anchors behavior. The next one is mixing method. What type of mixings? Is it just like a bulk systems that you pour two chemicals together and mix them? Or it's the cartridge method that I already introduced to you? So different mixings means different behaviors. The next important, and I make it important and emphasizing on the points by make them basically bold here. Hole cleaning is very important. When you drill the hole on a job site, you're creating a lot of dust into the hole. So hole cleaning, which is usually most of the time is brushing plus air blowing, is really important and is going to affect the bond and the behavior of the chemicals. The curing time is another factor, is very, very important when it comes to chemical anchors. It is a function of time and temperature, and I'm going to expand on these important points anyway. The next one is temperature. Temperature is very important. Chemicals in general, not only about the chemical anchors, chemicals in general, they are sensitive to temperatures. So usually when you have higher temperatures, it means you have more chemical reactions and, let's say, a faster reaction. And then the last one is sustained loads. The type of the loads in general have that they can affect the chemical anchor's behavior in a long term. Sustained loads means if you have a loading on your systems which is consistent and constant over the time. So that's going to basically not change, but basically show itself in a different way when it comes to chemical anchors. I put two boxes here, 100%, 25%, and 0%. And for the curing time, 100%, 25%. And I'm going to explain here. These are showing the behavior of the chemicals when we have 100% or the most correct way of cleaning the hose, and then 25%, which is the reduced cleaning. So the number of brushing and air blowing are reduced. For the curing time, we are dealing with 100% and 25%. And I'm going to show you if on a job site, instead of a correct installation, we have a reduced cleaning or curing, we have different behaviors. So bear with me for the next few slides. Cleaning methods. Why cleaning is so important. Through the hole cleaning, it is crucial for a strong adhesion. Through hole cleaning is crucial for a strong adhesion and load capacity for bonded anchors. So basically, the manufacturers on the market, they introduce something called manufacturers installation instructions or printed version, which is the MPII. And we are definitely referring to that. So I'll just give you an example here. If you have one chemical on the market and the installation instruction is, let's say, the printed version is something, and then you have another chemicals and the printing instruction is something else. So it shows that although they are both chemical anchors, but the installations are different and they can be different. So it's really important to, when it comes to hole cleaning, to just adhere to the printed versions of manufacturers' installation instructions. So basically what you have to do is just following whatever is written in the product's approval. It can be European or the US version of the approvals, whatever it is, we have just to stick to it and then perform the installation. Usually the normal applications, let's say DIY, small applications, a blowing pump, a manual blowing pump can be used to remove the dust from the hole. And these dusts are created when you drill the hole. And again, it's very important because if it's not done in a proper way, we're gonna end up having dust into the hole. And when you put chemicals into the hole, the chemicals, instead of sticking to the side of the hole, is going to stick to the dust. So basically the bond behavior or the resistance would be reduced. When it comes to more professional or very deep drilled hole, compressed air cleaning should be used. And again, how to use them, how long, or basically when they are all mentioned in manufacturer printed installation instruction. Hollow drill bits, if it's allowed, again, it's mentioned there and should be used according to that instruction. And then finally, when it's hole cleaning brushes, the correct size of the brushes and the correct type of the brushes should be used. If it's very deep, let's say drill holes, then the extension should be connected to the brushes to just make it possible to reach to the bottom of the drill hole. If we reduce the hole cleaning, if we don't clean it properly, we have reduction. I don't want to explain about numbers, but what is important here is we have like 30% reduction here, and it's huge. So it means if we don't have any cleanings, we are basically risking the system because the bond behavior or the resistance would be reduced. For bigger sizes, because the amount of dust inside the holes are quite considerable, that reduction is even more significant. It's around, let's say 65 to 70% reduction. So again, be careful when you deal with chemical anchors, they are very sensitive to cleaning, and make sure that you perform the cleaning properly. And these are the threaded rods when the cleaning were not perfect. You see, after pulling them out of the concrete, all the surface are dusty. So dust here everywhere. And then because we had, let's say, all those debris inside the holes, we can end up having air voids as well. The next thing that is very important is basically working time and curing time, as I explained. What is curing? Curing of a chemical or resin is defined as providing adequate temperature and time, which I highlighted here because there is a correlation between temperature and time, to allow the resin to achieve the desired properties, which is what we need is the adhesion or the curing for its intended use. And this simple graph here shows basically the warmer the weather or the environment gets, the curing time will be shorter. So if you are if it's during the winter and you are dealing with a chemical resin, usually the curing time is longer than the curing time for the same resin when it's summer. So how we can understand these times, the durations and everything, they are all mentioned in products approval. So when it comes to projects, the projects basically designer put something as the specification for the resin, and then there is the supervisor on the job sites responsible to check these times. And at the end, I think it's a responsibility of that person dealing with the chemicals to understand that the hotter it gets, the shorter the curing time and the working time as well. What is working time? Working time is the amount of time the installer has on a job site when they inject the resin into the hole, and basically they can work with the resin. So basically we call it gel time. So when it's not hard and cured, so you have like enough time to put the inserts and then basically start leaving it for the curing. Here, just again, another graph shows if the curing time is not respected, how much reduction we have is like 50% here. And then again, we have some reductions for larger sizes. What is important is the curing time should be always checked according to that approval and MPII by the company. Again, if you insert some chemical anchors into the hole, and then just before the chemical reaction is completed, and then you pull out basically the threaded rod or the insert, you can see the surface of the chemicals that is puffy, and it shows that the surface is really smooth and is not purely cured. So again, it's another phenomenon to show on the job site. We have to be patient and leave the chemicals for curing time, basically. Applicator tools is another aspects of the installation. If you have the chemicals, the most conventional manual tools available everywhere is just these hand injection tools. They are really cheap and suitable for normal DIY shallow installations. And if we are dealing with a few number of holes, if we are dealing with hundreds of holes, it's not really good to use manual tools because it's going to affect the installer's health and safety. Then we have the pneumatic tools, much quicker. The downside is that they are expensive. They are suitable for deep installation, and they are designed for high number of holes. So if you are dealing with hundreds of installation at the same time, this is one of the best options. The next one is battery tools. When you don't have enough space or, let's say, access to compressed air hoses and compressors in general, the pumps, it's better to use the battery tools. The downside is obviously we are dealing with the tools and a battery, and batteries are prone to life issues. And again, like the pneumatic tools, they are designed for a high number of holes and suitable for deep installation. Talking about Euclid product here, obviously we are talking about, we're going to talk about 308cc, and I brought just the MPI here to say these are not just pictures. When it comes to installations on the job sites, people should usually go through the installations, printed installation instruction, and just follow them based on what they are used for. For instance, if it's normal installation method, that normal section should be used. If it's a deep installation, then the section should be recalled, which is related to the deep embedment depth and overhead installations. Talking about the 308cc, 308cc, let's see what are the main aspects or features of the products. It's a pure epoxy resin. It's got the AC 308 approvals. It's a 3:1 ratio, and the ratio is just referring to the different volumes that we have of component A and component B. So that is the ratio referring to that. It is designed for extremely high bonder strength in cracked and uncracked concrete. From a designer or structural design perspective, most of the concretes are cracked unless the designer confirms that it's an uncracked concrete. So this product's basically the one that you want to go for because it's designed for both situation in concrete. There is no shrinkage when it comes to 308cc, and it's qualified for post-install rebar according to ACI 31819 chapter 25. And it can get even deeper embedment depth when it comes to rebar applications. So I'm talking about like a meter length of embedment depth, which is quite a deep considering the normal applications. It is approved for seismic design category F, and the user basically has 18 minutes working time with the chemical, which is quite a long time. When the temperature is 77. If you remember, we said there is a correlation between curing time and the temperature. And then great performance when it comes to sustained load. So if you're hanging or it's a structural applications that the load is going to be consistent through the time, this is the product everyone wants to go with. And the shelf life up to 2 years. This one is a little bit tricky because these 2 years.
No.
Sorry. The shelf life is up to 2 years when it's stored at 50 to 77 Fahrenheit. The features, again, it's designed for cracked and non-cracked, rebar, threaded rod applications, slow cure, which helps the installation to be performed when we're dealing with a very deep holes and installation on the job site. Diamond core drilling, which is used widely because we are dealing with concretes around the applications that are usually heavy reinforced. So again, even the smoothness of the surface is not going to stop us using this product, and it's less harmful because it's a styrene-free products anyway. When it comes to environmental aspects, we have all those let's say approvals available for the product, which would make it one of the best products on the market. As I said, they are designed for very high structural loads, deeper drill holes for post-install rebars, and when you have very close edge distances, if you can see here, and then for bracing systems, which is usually used for seismic damping systems, and obviously for external structures as well. Another products for the range, Duro range, is 200, Duro 200. This got AC 308 approval, high bond strengths in cracked and uncracked concrete. Again, it makes it suitable to be used in any sort of concrete. High performance in sustained loading. If it's a sustained load, the performance is fantastic. Impressive maximum service temperature, which is let's say 120 Fahrenheit to 179, and it's fully cured in 40 minutes. What does it mean? It means these can be used for applications that people usually need them to be done in a short period of time. So again, different feature, different products, different characteristics. Suitable for use in seismic design category B building, category F buildings, can be installed in freezing conditions with no loss in performance, which is something particular and really important because obviously the temperature, as we said, is going to affect the curing time, but it's not affecting the final performance of the products, which makes it really ideal for those applications. Shelf life up to 18 months when it's stored at 40 to 77 Fahrenheit. And again, just a summary of features and available approvals, which is another one here, NSF ANSI 61, which is designed for applications that the cured chemicals going to be in contact with potable water. So it can be, when it's cured, it can be in contact with water. So again, another test to confirm how good this product is. Another part explanation about different applications. It can be used for different types of applications, from dynamic loading to static loadings, and anchoring base plates in various environments. If it's cold or it's hot, it doesn't really matter. For anchoring, for rebar, and improving the behavior of the structures, and for overhead loads. Potential products for Euclid is Duro 150. It's just designed, it's a product useful for DIY applications, home improvements. It's for non-structural applications anyway. The applications like hand raise, satellite dishes, and to bike racks. So again, another handy product for those DIY and normal applications. Let's talk about the evaluation reports and how to use them. Again, this meeting or this training today is not going to be technical. I just highlighted some of the most important things can be taken out of an approval. For anchoring solution, complete product information and resistance, approved anchor types and sizes, temperature range, concrete condition and installations, bond strength, which is the most important things for designers, to the drilling methods. They all can be found inside the ESR 5352. And to get these numbers here and having the approvals, it means that chemical resin has been through a tremendous amount of testing. That's because of the safety. That product should be safe, so that's why it goes through all those testing programs. Talking about PIR or post-install rebar applications, we have sections dedicated for that. It's just helping to find the bar sizes and the corresponding embedment depth. Again, these informations on the approval should be used by qualified, competent designers. But it's good for you guys to understand that how good this product, because it can offer both for anchoring and post-install rebar applications. Again, a little bit just around installation instructions and installation details. Same document shows different things like the diameter and the drill size. So if you don't have drill size, basically you shouldn't change the drill size, because all those tests and performance are based on these numbers and they are fixed. Basically, for every single sizes, we have only one option for drill size. Let's consider one single anchor. We have one single anchor, a base plate, and this is concrete. We don't have any edges. We have infinite, so it's going to be far from the edge with that single anchor. When you consider that single anchor, it's like a conical shape when it comes to behavior or resistance. This is just showing the top view, which is a circle, and the side view, which is a triangle, and in general just showing one single anchor, let's say volume, that is affecting the resistance of the anchor. But when we have a group of anchors, 4 anchors and a base plate, these anchors are basically overlapping each other. Those volumes overlap each other, so they are going to affect the performance. So I just put them here just to say that when it comes to deal with a group of anchors, which is the most common cases, we don't usually have one single anchor. The designer or whoever is dealing with anchors should make sure that the final resistance of the systems is verified. And how that verifications happens? By considering different loads working on the system, which is like the loads that trying to shear off the anchor. So we call these loads in this direction shear load, in this direction shear load. And when the load is perpendicular to the surface of the base plate, we just call it a tension. Usually on a job site or on a real cases, design cases, we are dealing with a combination of them. Again, I mentioned them because it's important for the next slide, which is dealing with failure modes of anchors or post-install anchors in general. When we have only tension load, which is a load in line with the direction of anchors. So if we have a column and we have one load here working just in line with the column, then we have tension. If the anchor is really strong, we can have different failure modes. Failure modes can be a steel failure, concrete cone failure, pull-out failure, and then we have a combined situation, which is the concrete and the resin. And then we have concreting splitting failure and concreting blowout failure. This particular failure happens when the anchor is close to an edge. However, on the other hand, when we have the load that is starting and trying to shear off the anchor, we have different failure modes. So previous case, the load was in line. This time we have a load that is working here. For a column, the load would be a side load to the column. We have different failure modes here. A steel failure with lever arm when we have a shear that has some distance from the surface of the concrete. And then we have concrete pry-out failure. And finally, when we are close to an edge, we have something, a phenomenal or a failure mode called concrete edge failure. Again, these are mentioned because it's important for you to understand that things can go wrong, specifically if calculations are not performed by a competent design team. To helping that, Euclid can basically offer design, let's say, solutions for different applications. So these assessments of the anchoring can be done using the Euclid design software. And as you can see here, this is just a small part of a very long report. It can be used for those kind of contractors or people that are trying to move or substitute a product that is on a drawings, for instance, for a project, and they want to use Euclid product. So that software is designed for performing the design for that particular party and make sure that the product is verified for that particular application. Again, even about one of these formulas or failure modes, we can talk a lot, but today's meeting wasn't designed to go and dive into the technical side of the bit. It was more like a more practical and technical. And I hope you guys found it interesting and useful. Feel free just to let us know if you have any questions. Trezor, please help me if you have already some questions inside the question bar so we can just go on and answer those questions.
Yeah,
Thank
so
you.
I've been answering some questions in the chat. So, and some of them are still coming. One of those was why maximum embedment length of a 140 inch diameter anchor is limited to 25 inches. The thing is, in the theory of anchoring design, so you've got a range you work with. The min is 4 times the diameter of the anchor, and the maximum is 20 D, D being the diameter of the anchor. Therefore, for 1 1/4 of an inch, you have 25 inches. That was a question from Arturo. And then about the software, as Reza said during the presentation, this is the Euclid software to design anchor according to ACI 318.
Any more questions, Trezor?
There's one more question here. I see your evaluation and do not increase the strength when the concrete has high compressive strength.
Yeah, okay. So again, it's a really products dependent question. Some of the chemicals on the market, they don't show that much influence of the concrete class, let's say. But usually, normally for most of the products available on the market, when it comes to very high strength concrete, we are usually dealing with really, let's say, a smooth material as the base. So we usually tend to have a reduction when it comes to higher bond strength. And the reason is just that. Again, it's really product dependent phenomenal. Is some of the products, they are not that much affected, but for some of the products, it's a huge thing. But specifically, that's why there's a limit of C50-60, because there are concretes or C90-100, so very strong concretes on the market. But the downside is when you drill a hole in those concretes, you are usually having a more smooth holes, and that's why it's going to affect the bond of the chemicals.
Yeah, and also for example, European approval we use during the evaluation process, they take into account this increase in concrete strength, and there's a coefficient that is affected to the bond strength that can show a marginal, and in some cases, depending on how the chemical is behaving within the concrete, a substantial increase.
Yeah, that's true.
So,
but again, that's
yeah.
why we have the upper bound limited to C50-60, because anything after that, we have a reduction in behavior. But up to that point, the chemicals behave in a different way.
Yeah. Another question is, how do you take into account the the reinforced bars that are inside the concrete structures that is where we are installing anchors? So I think
that's the good question.
Mm-hmm.
Yeah. Well, when it comes to cracked concrete, for instance, and we have already reinforcements into the concrete, they are going to affect the edge behavior of the system, because if you consider the truss model when you're designing or dealing with anchoring theory, having some steel already into the concrete, it helps you to transfer some of those stresses, not only to the concrete, but also to the reinforcements. So again, it's going to improve the behavior. We have some sort of coefficients when it comes to crack concrete that can be defined into the program when we are dealing with the reinforced concrete. But in general, when it comes to anchor theory, the focus is, not the focus, the influential elements that are going to affect the behavior of the systems is more related to the concrete and the product's characteristics in itself. Although we have some effects on the reinforcement effects, but the main effects are coming from the products itself and the concrete as a substrate.
So another question. So
Yep.
where can we get this product? So that's for the commercial people. I think Oscar will be more geared to answer that question. But I think you can. Yeah. So,
well, with the con el área comercial podemos revisar eso. With sales department, we can check that.
okay. Can we clean the hole with water?
Yes, we can clean the hole with water, and actually it's one of the best solutions on the job sites, specifically when we are dealing with deep embedment depth. Pressurized water can be used to remove all those dust and debris from the hose. Just the only thing you have to consider is sometimes it's better, again, some of the chemicals are sensitive when they are installed in saturated or flooded holes concrete. So I usually say if you want to get the maximum strength out of the chemical or the product, even if you are washing the hole and removing all those dust and everything, it's better just to wait when they are saturated or a little bit dry.
So another question is, what is the lifespan of what is the lifespan of a structural chemical anchor? For example, 10, 15, 20, 50 years?
Again, lifespan is just the indication of how to say the life cycle of the product if everything is fine. So that is a tricky term anyway to deal with. If everything is okay in terms of base material, installation, everything is perfect, then we usually say they are designed for minimum 50. But at the moment in Europe, for instance, we are dealing with the life cycle of structures that is 100 years. And in the future, we are dealing with 120 or maybe more. The main reason is the longer the life cycle of the structures, the more sustainable they are. So at the same time, we have to make sure that whatever we use as a product has the same sort of level of life cycle. So yeah, the answer is 50 years. And in some cases, it is 100 years as well.
So another question, how do the design guidelines take into account fire risk? What I can say for the products that is approved for ICC report 308cc, it is not approved for fire exposure. However, the product that are approved for those, you can find those this information about the behavior under fire exposure in the approval documents, and the design methods. These you can find them in different codes, like in the ACI 318. I think the new version they've included a design method of anchors under fire. Yeah.
Mm-hmm. And if it's not on ACI directly, it's on one of the ICCs or AC codes anyway. But I'm sure that for DIRO 308cc, those information are available if you want.
Any other question? You can even jump in and ask it directly.
Yes, please.
¿Alguien gusta activar su micrófono?
Marielle, do you have a question? No,
Just a second. I think there's no more questions. Just give me a second to Mariel to finish the training, please.
Okay.
Yeah, sure.
Yeah, sure. Ah, there is Cesar Magana who say that he has a question.
Yeah, okay.
He's still typing it. What about dynamic load?
Yeah, if they are referring to, if the question is referring to seismic, then yeah, those products are, I mean, that product is approved for seismic applications, and there are some methods available for designers that they can basically, how to say, substitute the equivalent seismic actions to the corresponding dynamic loads. So let's say we have dealing with a pump or machinery connected to the base material, and it has some cyclic loading. There are some mathematical methods can be used for changing or shifting between two different types of load or action nature, and then compare it with the values mentioned inside the product's approval.
Okay. So another question, if we clean the hole with water,
Yeah.
How long do we have to wait before using, I think, before loading the anchor? So
well, the loading of the anchor is not a function of that. So some of the chemicals, they are sensitive. So basically, for some of the epoxy resins, we say that you can develop the curing time, and then if it's, let's say, 10 hours, it's going to be 20 hours if we are still dealing with the wet concrete. But again, it's not just about the saturation situation of the concrete, is about the temperature. Is that water cold? Is it going to make it, I don't know, the environment warmer, colder? These are the questions. But in general, we say it's better to wait longer when it comes to wet substrate.
So another interesting question, what the difference between the, I think it's a bond strength of the product, like the Dural 308cc and or the 200 or the 150?
Bond strength. Yeah, thank you. The bond strength is just one element. They are not necessarily, I would call them a weaker or a stronger products. They are all good products, but obviously for 150, because it's designed for normal DIY applications, it wasn't necessary for Euclid to put a very strong, let's say, resin into that, because it's not designed for structural applications anyway. But when it comes to 200 and 300 HCC, I would say they both really good products, but it really becomes the questions of when to use them, because they are different elements. We are talking about different drilling methods. We are talking about different curing time. If we are looking for something that cured faster, then we definitely go to 200. But if you're dealing with, let's say, deep PIR applications, then the answer is 308 cc. So again, bonder strength is only one element. Maybe they have, for some sizes, very similar bonder strength, but it really depends on the package.
Yeah, another question is similar to one we answered before. What is the minimum embedment depth? So the minimum, as I said, is 4D. So 4 times the diameter of the anchor, and the maximum is 20D. So for example, I'm putting a link in the chat that will send you to your ICC report. Table 1, you'll find for different anchors diameters, they give you all the installation parameters, included the maximum and the minimum embedment depth. So I can share my screen here so you can see what I'm talking about.
Yes, please. Thank you.
So I'm here. This is the ICC report for Dural 308. And you see for different anchors diameters, you have the recommended drill size that is here. And then that's for the fractional bars. And then here is for threaded rods. And they also give you the maximum tightening torque for different diameters. And here you have the range of embedment depth. The minimum is given here and the maximum is given here for threaded rod. And there's a similar table for reinforcement bars.
Nice.
Any more questions, or are we done?
I think we're done, Tresor.
Okay.
Thank you so much, Jafari and Tresor, for your presentation.
Appreciate it. Honestly, some of those questions were fantastic, and some of them were really into details. And we really enjoyed the engagement, because the more questions like them, it means that people are starting to engage. So people, thank you very much. Thanks. It was fantastic to be here. Thank you.
We could tell that we were facing practitioners and people who are involved into designing or just working with anchors or construction in general. So I think this was like a first one, but not the last one. If there are some aspects you want to know a bit more about, like to discuss a bit more technical differences between products, their performances, so you can just convey them to Oscar, and then we can organize another training more geared to going in depth, sorry, with on different other topics of your choice.
Okay. Yeah. Well, we hope to schedule another training or another meeting. Really appreciate your help, and well, thank you so much. Thank you, really appreciate it. So we are going to close the meeting. Thank you so much.
Thank you. Have a lovely rest of the day. Enjoy your day.
Well, all the best.
Bye.
All the best.
Gracias a todos los que se conectaron. Recuerden que estamos en un programa de capacitaciones para el segmento de construcción. Estas capacitaciones especiales para estructuristas las tenemos una vez al mes y esperamos verlos en la siguiente el próximo mes. Adicional, tenemos capacitaciones todos los lunes de 9 a 10 de la mañana con el segmento de construcción y de 10 a 11 con el segmento de concreto. Les recuerdo que esta capacitación la van a poder encontrar en nuestro canal de YouTube de 𝗣𝗥𝗢𝗚𝗧 traducida. Si alguien tiene alguna duda, aquí les vamos a poner en el chat el correo electrónico de Oscar Gómez, soporte técnico de aquí de México, y todas sus dudas las pueden ver con él. Agradecemos muchísimo su atención. Si les gustó esta presentación con nuestro soporte técnico de Euclid Chemical y les gustaría más presentaciones, les agradecemos sus reacciones para que hagamos más de este tipo y que tengan un excelente término de semana y nos vemos en la siguiente. Hasta luego.
Gracias.
Muchas gracias, Mariel.
Muchas gracias, Tresor.
Bye.
Muchas gracias.
Bye,
Bye-bye.
Teresa. Bye-bye.
Bye-bye.
Muchas gracias. Alarmed, my friends.